Hey, Mr. Gaiman, this is my VCast over uniform circular motion. If you couldn't tell by my voice or by the name on the slide, this is Robert Reed in your 5th period class. So we're going to dive right into this. Now, this section was a new concept. I did not learn this in the first year of physics, and this getting introduced to me was a new thing and really helped because I'm going into engineering in college. So my example is this. I'm not going to read it out because I have messed it up so many times. I don't want to talk about it. So y'all go ahead and read this just for a few seconds and I'll be right back. Okay, assuming that you finished it. So this question is looking for a few answers. It's looking for the magnitude of the force of the boom and then the direction of the force on the car when the car is moving at 5 meters per second. And then C and D are also looking for the same thing, except for the velocity is actually 12 meters per second instead of 5. So once you figure out the first part, it's relatively easy to find out the rest. It pretty much just falls into place. And really, it's just substitution. So here we go. The first thing you want to do is find the proper equation. So I felt the best fitting equation is F equals ma. It makes sense. We're looking for a force, so this is totally relative, and it's totally relative, all right? And so as you can see here, I replaced the force with centripetal force, and centripetal force equals mv squared over r. And then also on the right side of the equation, I dropped weight and then the force of the boom, so you can use those variables as well. And so once we go to apply it to A, you can see that for M on the right side of the equation, you're going to have to actually divide the weight by gravity in order to find the mass. And also you're going to multiply the velocity with it squared and then divided by 10, which is the radius of the movement, and subtract 5,000. So it's pretty self-explanatory, pretty much just substitution. And it comes out to be negative 3,724.49 newtons. You can round that if you'd like, but since the F is negative, the direction of the force of the boom is actually opposite of gravity, therefore it's up instead of down. I know first thought when you see negative you think it's down, but it's actually up since it is opposite of the boom. And then when we move over to part C, the same exact thing, pretty easy. 5,000 divided by 9.8. Which is to find the mass, and then 12 for the velocity instead of 5, divided by 10 minus 5,000 equals 2,346.938. Of course, you can round it again if you'd like, and that's in newtons. But this time, since the F is positive, the force of the boom is the same as gravity, and therefore it's down. So it kind of mixes it up. So when F is negative, it's up, and when it's positive, it's down. But this concludes my VCast. This was a 2-dot question, Mr. Gaiman. But once you found out the basics, it was relatively easy to solve. Thank you for paying attention. Here's just the conclusion with all the answers if you want to go over this and go over your work at the end. I hope my mic quality is swell. I bid you adieu.